Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about process control block in detail. So I request everyone to watch the complete video for better understanding. First, let me define what is a PCB and then I will discuss what information it will consist of. PCB, which is a process control block, is a data structure which stores the information about a particular process. Look at here, PCB is a data structure that stores information about a particular process, and whatever the information is available in the PCB will be useful by the CPU while executing the process. And remember one important point, each process will have its own PCB. Is it clear? Now what information will be available in a PCB is the attributes of a process. What are the attributes of a process? First let me list out them, then I will discuss about each one. The PCB consists of process ID. Okay, these all are we'll call attributes of a process. Then it will consist of program counter. Then it will have process state. Then you will have the priority of a particular process, and then you will have general purpose registers information. Okay, then you will have the list of open files. Then you will have the list of open devices, and then you will have the protection. Okay, so these all we will call it as attributes of a process. These attributes of a process will be there in a process control block. That's why I told you that each process have its own PCB. Okay, now let me discuss about each one in detail. First let me discuss about the process ID. Now if I want to recognize a person, I will recognize with the help of the name. Suppose if I want to call my friend, I know his name, so I can easily call. And similarly, we have our Aadhaar card number, PAN card number to recognize ourselves. Similarly, to recognize a process, we will have a process ID. Each process ID of a particular process will be unique. Okay, is it clear? So process ID is useful to recognize a process. And now let me discuss about the program counter. The program counter stores the address of the next instruction. Now let's take that a process consists of instruction I0, instruction I1, instruction I2, instruction I3. Now let's take that currently it is executing the instruction I0. Okay, then address of the next instruction will be there in the program counter. Okay, so it will have the address of instruction 1. While it is executing the instruction 1, CPU while executing the instruction 1, then it will have the address of instruction 2. Is it clear? So program counter is useful for you to store the address of next instruction. Okay, now let me discuss about the process state. We have several states in a process. One is new, ready, running, terminated, wait, suspended, ready. Now whenever a process is running, it will be there in one of the state, either in a new state or running state or ready state or terminated state. So in which state it is there, that information available here. Is it clear? Suppose let's take that a process is running, then that information will be available. Now a process is there in the ready state. Is it clear? That information will be available here. And now each process has its priority number, so that information will be available here. Now you can ask me, what is the use of a priority? Let's take that we have CPU scheduling algorithms, like we have first come first serve scheduling algorithm, shortest job first scheduling algorithm, shortest remaining time scheduling algorithm. Similarly, we have priority based scheduling algorithms also. Now the priority based scheduling algorithms are categorized into two parts. One is the non-preemptive scheduling algorithm, another one is preemptive priority based scheduling algorithm. Let's take that if it is a preemptive. Okay, now let's take that we have ready state and running state. Is it clear? Let's take that we have three processes such as P1, P2, P3 are there. Okay. And each process has its priority. Okay. Now let's take the priority of process P1 is 1, priority of process P2 is 2, priority of process P3 is 3. And let's consider that 3 is the highest priority, meaning is that the process which is having the value 3, the meaning is that it has highest priority as compared to the P2 and P1. So the lowest number recognize that this process has the lowest priority. Now if three processes are there in the ready state, the process which have highest priority will be scheduled or dispatched to the running state. Now process P3 will be scheduled and it will be running. Now at the same time, when the process P3 is running, let's take that process P4 has arrived to the ready state and its priority is 4. Then look at this one. The priority of a process P3 which is in running state is value is 3. Okay. And the process which is there in the ready state has the highest priority. If it is a preemptive based priority scheduling algorithm, then process P3 will be sent back to the ready state and process P4 will be scheduled to the running state. This information you will study in the priority based scheduling algorithms. Okay, I will discuss about scheduling algorithms in detail. But what is the purpose of priority is that which process has to given more priority will be recognized with the help of the priority of a process. Is it clear? Then general purpose registers. In the computer organization course, I have discussed about the general purpose registers. Now let me discuss with a simple example. I have an instruction called R0 is equal to R0 plus R1. Let's take that R0 and R1 are the registers. Now let's take that R0 is having the value 3 and R1 having the value 4. Is it clear? Now you have performed 3 plus 4 and the result will be stored in R0. Is it clear? Now let's take that after executing this one, there is a preemption. Is it clear? Are you able to understand? A process consists of instruction I0, I1, I2, I3. Okay. Now I1 instruction is this one. After executing the I1 instruction, there is a preemption. Then this process will go to the ready state. Now this information should be stored somewhere. Am I right or wrong? Is it clear? R0 is equal to 7. Let's take that next instruction is increment R0. Then you need to save this information R0 value as 7 because next instruction is increment R0. Okay, so you should not lose the information which is available in R0. So all this information which is available in general purpose registers while a process is executing, it will be stored in the PCB. Is it clear? So that is the information about the general purpose registers. Now let me discuss about the list of open files. Whenever we are running a process, we need to open certain files. Now all this information, whatever the files are open, those information you should store in the PCB. Is it clear? Okay. Then similarly, list of devices, whatever you have open. Let's take that you have given an instruction to the printer to print some things. And similarly, you have given an instruction to the fax machine. So all this information should be available somewhere. Is it clear? Whenever a process is running, it has several instructions. Now one instruction is to print something using the printer. Then you have to open the printer. Am I right or wrong? Is it clear? So you are sending a read signal to that one, write signal to that one. So all this information should be there whenever a process is executing. And then protection. Already I told you that each process has its own boundary. Now the process should not access the information which is available in another process. Am I right? Because each process has its own boundary. One is executable code will be there, and then global and static variables will be there, and you have a heap and the stack. So that is about the boundary about a process. So a process should not access the other process information. So that will be available with the protection. So these all we'll call it as attributes of a process, and all these attributes of a process will be stored in a PCB which is called as process control block. And I already discussed that each process has its own PCB, okay, which is process control block. Now, let's take that currently process P1, process P2, process P3 are currently available in the main memory. Now, P1 process PCB will be available in the main memory, and process P2 PCB will be available, and process P3 PCB also will be available, and all these PCBs will be linked using the linked list data structure. Is it clear? Okay, are you able to understand it or not? So each process has its own PCB, and whatever the process currently available in the main memory, all these PCB will be connected using the linked list data structure. So I hope you have understood what is a PCB, what is the use of PCB, and what information it will consist of. If you still have any doubts related to the PCB, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.